Hello, this is Michael Link. Really pleased to be here at the BigSurv20, talking to everybody around the globe. Here with my co-author, Gabriel Kreshuk, and we're going to talk about the use of two technologies that are out there, progressive web apps and computer vision, and how you can combine these two tools to help us in data collection, particularly with mobile devices that we have. We're going to provide a somewhat interesting, unique use case, and then talk about how this can be used at a broader level. Our focus for this started with looking at field data collectors. Like a lot of you all out there, we do a range of different field data collection types of efforts. Some of them are face-to-face surveys with households. Others, we go into classrooms and do observations. Perhaps we're looking for homeless individuals and doing counts. Also out looking at environmental assessments, safety concerns, a whole range of different things we have our field interviewers, field data collectors doing these days. And as we looked across some of these use cases, a couple things occurred to us. One is, how can we make data capture more easy for some of the folks that are out there, particularly those that are using more hand types of methods? How can we improve the time efficiencies to make things quicker and obviously either less expensive or allow folks to take mundane tasks and automate those and then have them do other higher level things? And at the same time, at least maintain the same data quality, if not improve the quality of what we're doing. Our focus then became, as far as the solution goes, is looking at two different types of technologies that both of these are off-the-shelf technologies. The first is a progressive web apps. These have actually been around for a while, and they're really starting to be leveraged quite a bit the past few years in more data collection types of activities. For those of you that aren't familiar, progressive web apps essentially allow you to have a website that functions locally like an app. So you're not actually building an app and downloading it, but you're actually using the power of a website. The nice thing is that this can be done offline. And at the same time, just like you do with an app, you can access the device's hardware, all of the various types of features that it has, whether it's the clock, or it's the scanner, or it's the GPS, or it's the camera. Those things can be accessed by the web app just the same as they can by a regular hard-coded, so to speak, app that you would download. The second is a different type of technology and has to do with extracting information out of visuals. And we call this computer vision. Essentially, what you're trying to do is identify types of objects within a picture and either count the number of objects or simply say whether an object is present or not. Effectively, you're using algorithms, machine learning behind the scenes to train an algorithm how to recognize through various shapes and patterns what is in a picture and then use that to extract information. Nice thing is, again, you can set thresholds and get something of what you might think of a confidence interval around some of the estimates that you get. What we've done here is actually take these two tools and combine them together, packaging a computer vision technique inside of a progressive web app to allow us not only to collect information in fairly remote places, but to perform data validation and quality control at the device level at the time that we're collecting information. And next, we'll kind of turn to the use case to show you what we mean by this. One of the big challenges that we have at APT is collecting information about mosquitoes. Interestingly enough, we do a lot of work in the developing world around the issue of mosquito eradication, trying to reduce the incidence of mosquito-borne illnesses in various places. And the way this is done is very labor intensive and hand done, as I'll show you in just a second. The solution we came up with after observing how this was done out in the field was to leverage an app using a basic smartphone and the camera that's on that smartphone to be able to take a picture rather than do some manual counting, and then develop a computer vision app behind the scenes that would allow these field interviewers to do their job quicker and faster. So let me show you what I mean by the manual process of what we're doing. One of the big things we need to know when we're trying to fight mosquito-borne illnesses is which mosquitoes are where and how many are there. We need to try to predict how many we anticipate in a particular area. So we know, should we send folks out to spray the area? Do we provide netting? Do we provide other types of assistance to local folks? And here, what you could see, the way you do this is you actually count mosquito eggs. You collect and count mosquito eggs. So if you look in the upper left-hand corner in the first picture, what you have there is an individual holding something called an ovitrap. These are simple traps. You put a piece of paper, special kind of paper, within this trap. They get placed out where mosquitoes typically lay their eggs, and you leave it out there for a while, and the mosquitoes will come and lay their eggs. And as you can see in slide 2 there, the individuals go back around, the field staff collect these papers, and then they bring them back, as you see in number 3, to a small central facility where they have to actually get magnifying glasses out and try to count the eggs to give a count of essentially how many we think that there are. That then allows us to project the number of potential mosquitoes in the area. And you can see in number 4, the team that has come back, field staff, they're all sitting around counting these eggs on papers. And you can see in number 5 what that paper looks like. In number 6, you get a sense for how small those eggs are. They're really small. There's a lot. Can you imagine what goes into having to do this count? Not only the time, effort, and energy, but the tediousness of this and the accuracy. So this was a perfect use case for us to be able to try to automate. Leveraging a smartphone and then leveraging off the shelf, again, not proprietary, but just simple off the shelf tools in the form of progressive web apps and computer vision. You can see the basic web app that we put together on the left-hand side. You can read the various features there. Essentially, we tried to make the interface very straightforward. Essentially, what happens is the folks still put the ovitraps out, they still put the paper out, they still collect the paper, but when they get back, rather than hand counting these, they simply take a photograph of sections of the paper. And then they run it through the algorithm that is running locally on the app, and it ends up giving you a count of the eggs, either single eggs or what it seems is clusters of eggs. On the right-hand side, you get a sense for kind of how this works, the computer vision components of this. The picture number 1, the original image, shows what that piece of paper looked like with the eggs on it. Looks similar to what we saw in the last slide where the folks were counting these by hand. Number 2 then is where we start to apply the application. It extracts out what seems to be the most obvious objects, based on, again, what it's been trained to look for. Here with the app, you can do a little bit of tuning to find certain thresholds, and that is something that the field interviewer does. Next, we actually have the algorithm go through and identify what it thinks are the eggs. Again, it's trained to look for certain patterns is what it's looking for. And then on the right-hand side, number 4, you can see what it has is the output, with the blues being what it deems as single mosquito eggs and the reds being clusters. And then ultimately, it gives you a count and a confidence interval. So you can imagine how much easier this approach is than trying to do this by hand. But of course, as measurement scientists here, we wanted to make sure that we were doing some comparisons. So how well did it compare? And we looked at 2 things. One was precision, and then the next thing I'll show you is timing. Here we looked at the comparison between 10 different pieces of paper, 10 different ovitrap papers, and had 4 different technicians do a count on each one of those. And then we applied the app, which is called the MEC Vision app, or Mosquito Egg Counter Vision app. And on the right-hand side there in the graphic, you can see the technicians' counts are in gray, and the app's count is in green. And you can see how there is great agreement across all 10 of the papers that we're seeing in terms of the number of eggs that were counted. So this gives us at least a preliminary sense that this is a pretty good device, giving us at least the same type of precision that we were getting with the hand counting. So turning next to time, and this is where we can see some really big differences. Again, here in the table, we see the 10 different papers with different counts of eggs on them. And in the gray, we've got the average amount of time that it took to complete the task in gray for the technicians and in green for the app. And you can see that the range for the technicians in doing hand counts was anywhere from 25 seconds with paper number 9, which presumably had very few eggs, to almost 5.5 minutes with paper 2, which we would guess had quite a few eggs. Overall, it took on average about 20 minutes for the technicians to count the 10 papers on average. When we did this with the app, you can see it only took about 10 seconds for each one, or about 2 minutes to do all 10 papers. And again, huge savings. So it didn't matter whether there were a lot of eggs to be counted or a few number of eggs. The app runs at the same speed, which gives you a lot of additional time now. Again, where you can free up a lot of these field folks from doing the mundane task of sitting there for hours on end trying to count these eggs, and they can then go on to do higher level tasks and cut their time doing the counting by using the app itself. If we think beyond this kind of use case that we just showed you, that you can imagine quite a bit that can be done. Again, with progressive web apps or computer vision, or the combination of the two. Obviously, they can be used individually as well. We do see progressive web apps being used to some degree as survey apps, either standalone or existing within existing websites. It allows you to do this offline data collection, so you don't have to worry about that persistent internet connection. Again, you can build in device level validation and quality control, so you can be applying those things at the point of collection. It does help to improve the respondent experience, and there's a lot of different things that we can use this for. Perhaps folks are doing complex data collection with a cross-sectional sample. Perhaps you're doing experience sampling where you're trying to have individuals do data collection over a particular time, looking at various different things that they might be doing and recording these incidences as they occur. Also then on the field staff side, as we've seen with this example, there's quite a bit that we can do in terms of improving data collection. We could even use this to provide documentation, checklists, other types of things, not just survey or data collection. On the computer vision side, I think it's really fascinating for our industry to get more and more into the leveraging of images. There's a lot of information there. In fact, think about it. We've got a whole generation now that has grown up on using Snapchat and Instagram and YouTube, and where visuals are the medium of communication. But there's a lot of ways that we can leverage visuals, whether we're interested in consumers, what they're buying off the shelves, whether we're interested in going into particular areas looking for safety hazards within a community or environmental issues and being able to capture those, a wide range of things that we might be able to do. Computer vision, as we've seen here, can help us to automate certain types of tasks. And again, this really helps us to scale up the type of work that we can be doing. Overall, both Gabriel and I really think that both progressive apps and computer vision have a great future in our industry. There's a lot of different things that they can be applied to, and we look forward to taking your questions during the Q&A session. So thank you very much.